In this video, I will be going over your Span Math Homework number 1 assignment. What we have right here is what you should be able to write on your scratch paper. When we actually take the test, I'm not going to provide you with any of this information. You'll have to know this information from memory. So let's look at number 1. 41.97% of the standard PSI range would equal how many PSI? I want you to notice here that I just say the standard PSI range. I don't give you the range. I'm going to expect you to have that memorized. When you get your scratch paper, write the information down first before you start doing your work. Alright, so 41.97, so that would be 0.4197. Since we're given a percentage, we can use formula number 1. If we're given a percentage, we can use formula number 1. So the percentage, 0.4197 times, remember that my number 2 numbers is the value I'm looking for. So what value am I looking for? So in this case, I'm looking for PSI. So my number 2 numbers here would be PSI. So it's 41.97 times, open parentheses, 15 minus 3, close parentheses, plus 3. 41.97% of 3 to 15 is 8.04 PSI. Also, I'm going to want you to show your work, but I'm not going to show my work every time because I'm trying to write with a mouse and it just takes too long. 15.56% of the standard PSI range would equal how many PSI? I will do it on this one example. 0.1556 times standard PSI range is 15 minus 3 plus 3. And we're looking for a PSI. How many PSI would that be? So I punch it into my calculator. 0.1556 times 15 minus 3 plus 3. That would equal 4.87 PSI. Number 3, 85.22% of the standard milliamp range would equal how many milliamps? Alright, so I went ahead and wrote my work out here. I want yours to be neater than this, but I'm actually writing with a mouse, as I said, so it's hard to write. So it would be, looking at the calculator, 0.8522 times, open parentheses, 20 minus 4 plus 4. 82% of 4 to 20 milliamps is 17.64 milliamps. You're just going to put in the number. You're not going to put little m big A. One thing that can help you check your work is if we want to find 50% of span, there's a technique for doing that. You take your upper range value, which with milliamps is 20, plus your lower range value, 4, equals 24. You divide it by 2. 24 divided by 2 gives you 12. 12 milliamps is 50% of span. So here when it asks me what is 85.22% of the standard milliamp range, well, 85% I know has to be more than 12 because 12 is 50%. 82% is more than 50%, obviously, so I know my answer's got to be more than 12. That's just a quick check of my work. Give me a ballpark range. Go back up to number 2 and looking at my technique here for finding 50%, since I'm dealing with PSI, it's always going to be 3 to 15. Well, 3 plus 15 is 18, divided by 2 is 9. So I know that 9 PSI is 50% of that scale, of that span. So when we're talking about 15%, I know that should be below 9 because I'm less than 50%. So I know it should be less than 9 PSI. That's just a quick way to check your work. Okay, number 4, how much PSI would be applied? So right now I know that I'm looking for PSI. I'm not given a percentage, so I'm going to be using formula number 2. And I'm looking for PSI. So I know that my number 2 values, the numbers to the right of my multiplication sign, is what I'm looking for. I'm looking for a PSI. How much PSI would be applied to the control valve actuator if an 7.84 milliamp signal were received by the control valve transducer? So the numbers I'm given, in this case I'm given milliamps. So my number 1 numbers are going to be the values I'm given. So looking at the calculator, I'm going to open my parentheses, hit over under. I'm given a 7.84 milliamps, so I know everything to the left of my multiplication sign in my formula has to be milliamps. So it's 7.84 minus 4 over 20 minus 4, because that's my milliamp range. Scroll over, close parentheses, times. Now I'm going to punch in the numbers of what I'm looking for, the range I'm looking for a PSI. So my range will be 15 minus 3, close parentheses, plus 3. 5.88. If the transducer receives 7.84 milliamps, it's going to produce a 5.88 PSI signal. Number 5, 74.13% of the standard milliamp range would equal how many milliamps? Well, I've got a percentage, so I can use formula number 1, 0.7413 times, open parentheses, 20 minus 4, close parentheses, plus 4. 15.86. 74% is more than 50%, and my answer is more than 12. So, quick check of that. How much PSI would be applied to the control valve actuator if a 15.03 milliamp signal were received by the control valve transducer? So, we're given a milliamp, we're looking for a PSI. Open, over, under, 15.03 milliamps minus 4 over 20 minus 4, scroll over, close parentheses, times. Okay, that's all of my upper range values of my number 1 numbers. Now I'm looking at my number 2 numbers, what I'm looking for. 15 minus 3 plus 3 gives me 11.27 PSI. Number 7. How many milliamps would be required to apply a pressure of 8.86 PSI? So now I'm looking for milliamps. So I'm going to open parentheses, hit over, under. I'm given a PSI. So I put all my PSI numbers in parentheses to start with. Times, open. Now I put in what I'm looking for, how many milliamps. Okay, so it would take 11.57 milliamps to produce a 8.68 PSI pressure. 28.91% of the standard PSI range would equal how many PSI? Well, we're given a percentage, so this one's pretty easy. 0.2891 times 15 minus 3 plus 3. 28.91% would equal 6.41. 47, I mean. And so I'm below 50%, so I'm below 9 PSI, so I roughly know that it's at least in the right ballpark. 78.16% of the standard PSI range, so 0.7816 times PSI range is 15 minus 3 plus 3 gives me 12.38 PSI. Number 10, how many milliamps would be required to apply a pressure of 5.98 PSI to the control valve actuator? So I'm looking for milliamps and I'm given PSI. 5.98 minus 3 over 15 minus 3. 3 to 15, that's my range, times, open this, milliamps, 20 minus 4 plus 4, 7.97. And once you submit your quiz, it will give you your grade, and you'll see if you missed anything, and it'll show you the correct answer if you did miss anything. So that's a quick overview of how to do span math homework number 1.